as usual, we usually start with this slide, and I try to keep it interesting, explaining that what Design X is and kind of add a few more details here and there. But no matter what, I need to communicate to some people that maybe this is their first time joining the webinar, that this webinar is really focusing on our Geomagic Design X product, which is a software product that's focused on reverse engineering or recreating objects that primarily come from scan data or scanning devices like you'll see on the left-hand side. So many devices in the industry create many types of 3D information, whether it comes from a laser scanning or a white light scanner or all kinds of different technologies, even like CT or MRI data. And that type of information is 3D information, but it's a different model family or families, depending on which objects you're getting the scan data from. And throughout the many years of our experience, we decided to make a product that would take that sort of information, work with it, and allow you to process it in a variety of different ways in order to get it over to the manufacturing process, whether it's CAD, CNC, additive, or lots of other different applications. And this webinar focuses on the success stories, different specific use cases of how we've used Design X within the industry and successfully produced interesting applications and outputs. Before we get into today's applications, I wanted to take a moment and talk about the Geomagic Design X product tiers. So over the course of this webinar series, I've primarily discussed Geomagic Design X Pro and all the applications associated with it. But I wanted to make everyone aware that while I'm talking about Design X Pro, there are two other tiers to this product portfolio that I just wanted to make aware. And I'll bring this up too at the end, just to make sure everybody has an idea of what they are. But Design X has 3 product tiers. And as this slide shows, it gives you some color commentary on some of the functionality in each one. And we even have PDF documents available that we can send out that have like more specific details on which tools are in which product level. But the way I tend to discuss Go, Plus, and Pro are based on some distinctives. So Go has no plugins built into it, and it's designed for extracting, is the way I like to say it. It does have some basic modeling in it, but in my opinion, the really good workflow for Design X Go is it's a cost-effective way to enter into the Design X product portfolio and extract mesh sketches and primitive shapes and transfer those over to CAD to do a lot of the heavy lifting of modeling on the other side. So Design X does all the heavy lifting of working with scan data. You extract by importing meshes and point clouds from wherever you get them from, whether it's a handheld scanner or different devices that can output that information. You extract by cutting cross sections and primitives, throw it over to your favorite flavor of CAD, and then finish the model over there. Now, that doesn't mean Design X Go can't do any of that, but that's kind of the lane that it's designed to work in. Now, Design X Plus has basic modeling, it has scanner plugins, and of course, all 3 of these, as you're kind of understanding here, have the live transfer tool, which will allow you to do a live transfer over to CAD, whether it's SolidWorks, Creo, NX, Inventor, CAD packages like that, with the history tree. So all 3 of these have that functionality built in. Now this mid-level one, the Plus, it also has the ability to add the scanner plugins, as I just mentioned, and then it has basic solid and surface modeling in there. So you have another graduation up this line to where if you need plugins, that's a big differentiator here. And if you need a little bit more modeling tools, and then of course Pro has all the stuff that we've been talking about, where it has everything that we make. It is the highest end tier here that has all the tools that we have. Now, another distinctive of our product line is the fact that you can pay the difference to move up the tiers. So if you currently are out there and you have Design X Go or Plus, and you're finding that you do a lot more reverse engineering now that you have this tool in your pocket, and you think that you might be able to streamline and make the process faster by moving up the tiers, which is definitely the case, you can pay the difference you can get with our salespeople and move up to the next tier just by paying the difference between the two. So that is just from a high level. That's a really nice benefit. So if you Go is how you entered into become a customer of ours and you're interested in Plus or Pro, you could always on year number 2 decide while you're renewing your maintenance to move up to Plus and then move up to Pro. And then this makes it so you had software that entire time, but you don't have all of the DX Pro investment at once. You can just make that over the course of upgrades. I really enjoy the fact that we have that method for moving up. And I also wanted to just bring that up because I haven't discussed this at length during the webinar. So with that, let's go ahead and get started with our applications. For today's webinar, we're going to follow a slightly different format as we have in the past. So in the past, we've been doing 1 to 2 applications where I discuss where Design X has been used in a success story of sorts, just showing the different tools that were involved in accomplishing that task. And today what we're going to do is we're going to do one application, but we're going to do wire to wire from beginning to end of an entire project and walk through that and show how that process goes from scanning, scan processing, alignment, all of that, modeling, output. So today's is going to be kind of a different format. And as we go forward, I will also solicit everyone in the audience for ideas of topics that you might want to cover and applications, any general ideas based on what we've done so far here. If you have any comments and feedback of things that you might want to see, I can go ahead and add them to my list of things that I can utilize for this webinar. So we do have lots of customer applications that we've worked on that are awesome, but sometimes mixing this content up a little bit and allowing everyone to see different types of workflows and even more granular workflows like today's. So today's application is going to be a consumer product. And if I just go to the next slide here, we used the ARM here right there, this specific one. I used it and I scanned the data. And we scanned it and flipped it over from a different direction, as you'll see here in the demonstration portion, where I scanned this with the laser here on this arm here. And what I did is then brought it in and did this application here. So as you can see, this is a consumer product, and this is a soap tank that goes to a pressure washer, and it mounts down below here. And what I was able to do is take that and scan it and reverse engineer it. And I figured today for our application, why not go ahead and show that process of how I got there. So today's is going to be a little bit extensive, so I might as well just jump right in and switch over to Design X. So with that, let's go ahead and bring up Design X. So here we got DX open. And you can see right away I have a scan of the part sitting here, and this is position number 1. So obviously I've already scanned the part, and I'm basically pretending, okay, I scanned the part, I flipped it over in this direction, and you see I got the fixture around it and everything. And then I put the scanner away, and that's where I'm picking up here. This is just the raw scan data, and we will take it from there. If you see, if I just click on meshes here, I have 29 million polyfaces. So there we go. We are ready to jump in here. So with that, I'll just go ahead and just start processing the data. I purposely left overspray and things like that because there are things that I could have done to make it so there isn't as much scan, but not every application is like that. Like not every scanner or not every part are you able to do that with. So in this instance, what I'm going to do is just leave some of that so then I can show how I would go about repairing it, just the techniques that I use to clean up the scans and go from there. And I'll just highlight some things. Some of them may be applicable to this part. Sometimes they're not applicable to this part, but I just think of things that are helpful to know as you're working with the scan data. You know, I'm just going to try to throw in some color commentary from there. So yeah, some people will immediately say, "Why don't you use a clipping plane and things like that?" I do have the ability to use a clipping plane. Not every scanner or person has that ability, so I just left it in here because it gives me a chance to show more stuff, more tools for you guys to pick up on. So there, I went ahead and deleted some of that information, and then you'll see here, I'll just rotate this and delete some of this now here. And I'm using certain tools that we've talked about before. Right now I'm using that polygon selector tool, making sure I have select through on, because that's a popular mistake, is leaving this back faces on to where you don't actually select through. And sometimes it's just easier to use this polygon selector tool. I will say in general, as soon as I'm done using the polygon selector tool, I turn it off and I stop. I switch back to the rectangle selector because it's kind of a tool that as soon as you click, it wants you to close the polygon selection over and over again. So it's a little bit annoying. So you can't just leave it on this tool. I always go back to the default rectangle tool when I'm done there. Because if I just accidentally click or whatever, or I'm trying to select something else that's not scan data, that's where it comes into play there. And then for stuff like this right now, you see that I got that little lip around the edge there. There are things that I can do. You know, sometimes I'll just go ahead and do this and then zoom out. And then you'll see that there'll be selections on the other side of the part. So sometimes I'll go ahead and just zoom out, hold control, and accidentally click on that plane there. Sometimes definitely hiding the planes during the scan editing phase is definitely a good idea. So I just did a giant deselect in case there are other triangles there selected. So let me do it again because I messed it up by clicking on the plane. But you know, I could go around the rim and you see it's going to select other things throughout the model. So I can then toggle back here to this, hold control, and deselect from the other. That way I don't have any other triangles selected there. So that's one way to do it. You can even use it takes a second to do, but you could use the isolation tool like, you know what, let's do this. Maybe select here, and then you could say set view clip from selection. You could do something like that. That's another way to do it. I'm just trying to think of different methods that I've seen people use or I've used in the past. So you could just like create a view clip, and and then set view clip from selection and say reset view clip and then come back to the select everything. That is a nice, clean, quick way that I like to do it. So from there, now we're ready to go ahead and just take this. We got 30 million points describing this part. One thing that I tend to do is I'll come over and I will hit save. So I'll just come over here and then I stage my parts here. So you see I have a general name and then I have scan. Now I might switch over to what I call editing the scan. And then I'll revise those up. And then let me just put this in a slightly different folder here, just to keep it nice and organized here. And I like to do that. So now I'm no longer in the scanning phase of my project. I'm in the editing phase. And then what happens after I edit, then I align, then I merge, and then I model. And I kind of have those stages and how I label. And then I even revise the model up sometimes. If I'm editing and I need to make a change that I'm unsure about, I'll go ahead and do a save as. I'll save the file, I'll do a save as, and I'll rev it up to the next number. Instead of edit 01, I'll do edit 02. That way I have something to go back to and work with. So now let's go ahead and align these two together. So we'll come over to align between scan data, and I'll say local based on picked points. I'll click group 1 and group 2. So I select which object is my reference and which one is my moving. So this one down here is going to move to the other one. And I tend to like to just align them together on screen first, like so. And then come in and zoom in and add your points there. So I will add a point, and you see I like to add point, so I don't get them mixed up. And as you can see here, they don't have to be like perfect locations, just got to be kind of close. It does help sometimes to find little monuments somewhere to help you select an area. And you see here, it's close enough. I use 3, and then I can go ahead and hit the checkbox here, and it will then do the best fit. But you notice I didn't hit the box up here. I just want to run the alignment right here first, and then I'm going to switch over to global fine or global and fine and run that before I get out of this command. I want to go ahead and do a fine adjustments best fit afterwards that uses a little more of the data. So now you see that it's finished. I'll switch over to global and fine. And then I'll just throw everything in moving. In my settings, I actually bump this up to 11. And then these are the settings that I tend to start off with here. So I like 11 and then auto is a default, I believe. And then I'll run global fine and let it best fit all of the individual shells together. Now that is finished, I'll just go ahead and accept that. And we have now an aligned data set. Now we'll just go ahead and jump right on over into the merge. So we'll run merge on this data, volume merge, go ahead and select everything. And then I always bump this up 2 ticks or 1 from the top. Also, make sure that this is unchecked. We don't want it to remove the original data. We want it to keep it just in case we need it, and then hit OK and let that cook. Once that is done, we will have a merged mesh, and we'll go ahead and rev up my file and save it as merged, and then we'll jump into the alignment phase. So now that finished, you see that we have both groups, and I'll just turn that off here. And then here is the merged scan, and then both other ones. So what I tend to do is I come in, I go ahead and I rev that up, and I just call this merged. And then what we'll go ahead and do is just go ahead and get rid of the others. So I'll just shift select those and nuke those. Then we will just resave. There we go. And so now after merge, we are at 15 million triangles. So a lot of times I'll go ahead and decimate it down. I only need around 2. And go ahead and decimate that down to around 2 million. And then I have a couple more things to do before we start modeling. So now we are down to the 2 million. I also like to either run global remesh or enhanced shape. So let's do enhanced shape, and I'll leave the enhanced level around somewhere there and hit OK. And then we will do a couple mesh cleanup things. It's not necessarily necessary to do that much, but it helps to go ahead and do some mesh cleanup stuff. So if I come over here, and I like to start off with the healing wizard and let it go through and find all the floating bits and things like that out in space. And then I just go ahead and accept whatever it tells me is wrong, and I'll go ahead and just accept that. And then it almost never finds everything and heals everything in one shot. So after it's done that, I will go ahead and exit out of the command, as you'll see in a second. So it says it wasn't able to heal everything. Do you want to try again? Yes. Go ahead and give it the old college try. After the college try, it says failed to heal. Okay, cool. And then it leaves things selected when it exits. So if I just hit the delete key on the keyboard, this is Design X best kept secret here. So I just hit the delete key, and it will delete those triangles for me. Now, I can go back in. Let's see what it finds. Some small clusters somewhere. Okay, cool. And it was able to fix it that time. So that's good, good. Now, if we talk about some of the manual tools, I can come in with just hole filling, and select boundaries like there. You see there, I was able to just do a hole fill. You don't have to exit out of the tool like I just did. You can actually window in and say, I want to select all of those and fill all those at once if I want to. I could do a Control A. Some of these things, I don't have to fix all this for what we're trying to do today, but some of this stuff I can come in and just select it, and you'll see that there's some floating bits and things like that. If you have a floating area here, you can do a couple things. I can click on the floating thing itself. I can click on the overall piece. So if I click on the overall piece, this is the classic inverse selection, delete all the floating bits in space, and then come in and do hole fill. And you'll notice, there we go. Okay, that was something from the other side. And then I can come in and just say, hey, I want to fix those little things, and keep right on going. And just look around and see if there's anything else that I might have thrown away here. And I just threw away the cap on accident, so I'm just going to hit undo. So you'll see that I when I did this selection, I noticed that it only did that. So I need to select both of those, and that's where undo can sometimes save your tuchus there. What I might do here is come in and come over here and take the brush and just, I don't know, I just feel like doing it this way. Disconnecting that piece and maybe disconnecting this piece here and get rid of this little other floating piece and save some of the others. You'll see what I mean here in a minute. This is all just personal preference if you want to go about doing it this way. And then we'll see here. What do we got? What we got left there? Okay. Yeah. Let's go ahead and get that. I'm just disconnecting these pieces that are sitting there. Now we'll go ahead and do what we just did where we select, inverse, get rid of that. Then come into whole fill. It's going to say, yeah, you got bits and pieces you need to repair now. But the reason why I wanted to do this is I'll just go ahead and I want to keep the cap and keep it connected. So I'm just going to drag that and let it create a little, because that's kind of what it is, but it goes to a little retaining ring thing that I'm not going to bother modeling here. And then I can, if I wanted to, sometimes these little things bother me and I just have to fix them because I know I can. Just come in and just do a partial fill or whatever. I don't have to actually repair that. But now that's connected, so it won't go away by accident now. And then I'll come in and run Healing Wizard and let it fix the pieces and go from there. So now we are ready to align this to the world. So if I turn on my planes, you'll see floating out in space here, turn on the origin. Yeah. So now we're going to go ahead and create some regions. I'll come over here and grab the Smart Selector tool and select that geometry and come in here and say I want to insert a region. And then we'll do that also right here. Insert a region. Then we will toggle over and look at the part in this direction and say I want to create a plane, draw a line down the middle. Hit OK there. Now if I select the plane and the mesh over there in the tree and open it up, it'll automatically go to mirror plane and allow me to calculate a symmetry plane down the middle here. You'll see that it calculated a second plane there. So now I'm able to come back and use these for alignment purposes. But before I do, I always check my regions. So you see I click on that region and it's seeing that as a freeform. So I'm going to come over and switch that to a plane, and that's already a plane. So we can come to interactive alignment, hit next, and I can select my 3 planes, and you'll see it'll intersect the 3 planes to constrain the position only. And then I can come over and say I would like to constrain my x-axis to that direction and my y-axis to this direction. And you can see that I can constrain the rotation separate from the position there. And then if I just hit accept, you'll see now I have an alignment. If I just hit the front view, I am now aligned to the world, and I can go ahead and start modeling. So we'll go ahead and save our part as aligned. Then I'll do a save as and do one. So now we are in the modeling phase. So we will begin that whole section now. So there are a whole host of ways that you can model this. As I usually preface, anytime we model something, I like to point out that there are different ways of going about modeling. So just to make sure to let everybody know that there's a whole host of ways of doing it. And I will just take one that kind of highlights some tools that I would like to highlight here, and we will get started. So I'll go ahead and select that top plane and do a mesh sketch on it. And you see that we can, as usual, we can drag that mesh sketch wherever we want throughout the part. And then we also have the ability to silhouette the entire thing if we wanted to. So we could come over here and do this, silhouette the entire part. Now, for this, I'm going to say that I want to eliminate that from there. So what I can do is I could say, maybe let's silhouette a portion of it like so. And actually, let's go down to the bottom and extend this up like that to include that. Because I want to basically get this section as well. So now we come in and then hit OK. It takes us inside of the mesh sketch. I can turn that off, and we can go ahead and draw our mesh sketch. Oh, and I'm noticing something going on over here. So I can accept that mesh sketch, by the way, turn my mesh on, and I can come back and hit edit mesh sketch. And you see what I think, yep, it just happened to, like me moving the box around, somehow move this side in a little bit. And I noticed that before I went ahead and start drawing. But I wanted to point out that you can do this at any moment. You can move that mesh sketch boundary and then accept, and you can basically edit it on the fly. And then now I can come back over to mesh sketch. That's an important thing, that if you mess up, you can do that. Now I turn that off. And the way I'm going to model this is we'll come over here and I'm going to fit, double click to accept that. And we will go ahead and do a line down here. You'll see the approach that I'm taking here as we continue to model. But we can go ahead and snap it there. You can, if you want to, do a center line like that and say I want to mirror across the symmetry line. There we go. And then come trim everything. So we'll just go ahead and do corner trims. And I'm going to leave fillets out of this for right now. So I'm going to model this with sharps at the moment. You could add these fillets in, but the way I'm going to choose to model this, you'll see here in a second how we go about doing it. So now I'll go ahead and extrude that. And we can look at it from the side view here. And I can make the determination. Looks like it's 115 is what I want to extend it down. And remember, this is an injection molded part, so it's got tons of error. And there's a lot of freedom to override the dimensions and make them what they should be. So I'll go ahead and save. And then now what I'm going to do is hide the solid. I'll come over here, and you see that I like doing regions a lot of times kind of on the fly as I go. I'll create regions. So we're going to create a region there and create a region there. And let's see if we can do both of these, because you see that's at an angle and this is at an angle. And here's my solid. I'm going to see if my extrusion wizard will get both of these. So I'm going to say I want that, and I'm going to constrain it to this plane, and I'm going to tell it that these are cuts, solid cuts. Let's see where we go with this, see if we can get it to work. So it went ahead and drew all of it at once. Let's just change the resolution there. I might just do them as independent pieces here. So we'll just go back and maybe just clear it out and do this one as solid cut. And hit next. Actually hit next this time. There we go. So I'm going to do them as separate pieces. It's just more editing to do it that way. And you see there. And then if I want to tweak that in any way I can, turn all that off, go normal to. You can do that. I'm just showing that it's there, that these give you editable information there. So we'll turn this off. We will fit this bottom. I was thinking doing the same thing, selecting this, constrain it here, solid cut. And I'm going to let it create that even though it's not exactly what I want. And I'll come back, edit. And then we will select this, corner trim, and we'll say that's what we want. And remember, there's lots of error in that because it's very warped. So there we've done our first two cuts, and we'll go ahead and save our part. Now, let's go ahead and select this and that. So I'm selecting the point and the edge, and let's just create a plane on it. Hit OK and turn this off. Now, this at first looks like one constant sweep all the way around, but this has a ledge over here. This is where scan data comes into play. This does not. So I'm going to do them as separate pieces. So we'll come over and turn the mesh on, use this guy, and drag this over. Just somewhere in the middle there. Okay. And I can slice multiple sections and things like that, but just for the sake of what we're doing here, we'll just go ahead and slice one section and model it from there. Like that. And we'll extend this out. So there we have that. And then I can say, let's go ahead and extrude that along that direction. And we'll just do it in the opposite direction at least a little bit to make sure we have it all the way out. And we can go ahead and mirror that across. So if we just come over here, it will just say this body mirrored across this plane here. One more time there. And then we'll do the same thing. Let's just go ahead and hide some stuff here with the front. And we'll go ahead and extend this. Extend that. And extrude, mid-plane. And then from there, we'll go say, let's trim our surfaces together. So I'm going to select all of them, target all of them, keep this, that, and we've trimmed all of that together. Now that we have that all trimmed together, we'll go ahead and turn this back on here and say, let's go ahead and cut this body with this surface like that, and then turn off our surface there and see what we got so far. And then the next step is let's go ahead and add fillets to these right here. So I'm going to click on this and I'm going to hit calculate. I'm going to say calculate from the mesh what you think that should be. And you can do that on either side. And then I'm going to apply this to there and turn on the mesh. And let's do that again. $70. That's what I typed in 80. I don't know why. Yeah, it looks beautiful. And for our next trick, we'll go ahead and fillet this too. Remember the 80, but we'll just let it calculate here. It looks like 70 millimeters is a good number. So you're seeing where we're going with this so far. And then we'll go up here. Let it calculate, see where we get. We'll type in 7. Turn off the mesh. Let's go ahead and apply a fillet here. Hit calculate from the mesh. Let's do like 16. Oh, and I accepted it. Go ahead and put them in the same feature here so they're together. There we go. Now let's go ahead and apply some fillets here. All the way around. And hit calculate there. Should be around 6, I think, based on what we've done so far. Oh, yep. Now let's go ahead and apply fillets to all of this. I accidentally clicked the face. Accidentally clicked that edge. There we go. All right, so let's calculate it. 9.5. Let me just make sure I got them all there. I think I did. We'll go ahead and save again. Turn the solid off. Let's go ahead and jump in on these guys. Grab this. Okay, and with our selection tools, let's do this. Hold Alt and you can change the size of your brush. Not perfect, but good enough for what we're trying to do. There we go. Come over to region. I just like saving my selections by using the regions there. And yes, it's going to be bowed here. You can see it. It's like visually arched. But I'm still going to say, let's go ahead and just give me your best try here. Solid insert. Accept that. And then actually I want to extend it past here. Edit that. Trim this. And just re-snap that. There we go. Now I'm going to grab that top surface here, create a mesh sketch, bump it up. Just a little bit. There we go. That's what I want. And turn this stuff off. And just best fit to these. And if I were doing this for manufacturing, I would take time and dimension all this stuff a little more, right? But the idea here is what we're trying to accomplish here. And you'll see where I'm going with this in a second. I'm just going to go ahead and make that and make this way. So there we go. We'll turn on the solid. So I did that ahead of time because I want to do two things. One of them, I wanted to use this for patterning. So if I come over and I say I want to pattern this body on this direction, and let's just clear that out and reselect that. You can do a filter selection here and say I want just the edge, and then I can just flip-flop that. So it's 16 millimeter difference. You can drag this out. What I tend to do is I like to use the furthest instance to help me figure out the delta in the middle. If I just try to set my distance by the first one and then they'll propagate way out, I can use the accuracy of that distance to help me dial that up. There we go. And then I could do it I could have not put this boundary around there. I could have just extruded this and do the difference. But something about the way DX does the difference is a little bit different than some of the other softwares out there. And it was just easier for me to draw an outer boundary around this. And I can say cut selected bodies. So just hide my mesh, hide this guy, and I can say cut all these. I could do this in 2 steps with booleans, but you got it. You understand. So now I have that, and we can go ahead and mirror these bodies across this plane. And we don't want that one. Actually, click this again and take that extrude out. There we go. Turn the mesh on and take a gander of where we're at so far. And then save. I think we can go to where we merge this all together now. So I'll just come over to Boolean, merge all of that. So now we are merged. Turn the mesh on. Look at this here. Let's go ahead and go to regions. There we go. Extrusion. Solid cut. And we'll just bump this in. Yeah, it's good enough for me. Turn this on. Oops. There we go. It would do like 6. Then we'll do this. Calculate 7 there. Yeah, that looks good. Now we'll go ahead and turn the mesh on. Come up here. Go to regions again. Grab this. And this may be on an angle for a reason. I'm just going to make the determination that it is. It could be bent. You just have to have a general understanding of making a decision on what you're going to do with it. So now for this, sometimes you can rough in a shape like this sometimes by using the circles if there's enough data there. Like that could be a way to do it, or you can do it based on the straight sides. It just depends on how much data you have. Sometimes this one way is easier than another. Another thing you can do is use the slot tool. I know this looks weird, but you could start off with that and then come in like that. And sometimes the snapping there's a lot of things to snap to when you're in here. Corner trim. I should have just stayed there. Power trims. So 2.5. There we go. And if I forgot something, remember, we can come back here. Let me just see if I didn't have the holes in there. So I could redo the sketch, or I could just do another one of these in silhouette. If I wanted to do that, silhouette those holes and do it as a separate feature. Yeah, I'm just doing extra work here. Sometimes the easiest way is just to do another one. You know, it just depends on what you're doing there. And there you go. And we can also come back and add fillets here. There. There we go. Now for up here, I'm just going to take the easier, quicker way out here. Insert a region. Come over to revolve. And yes, it's not going to give me exactly what I want on this one, but I'm going to accept it and come in here and let's turn on that mesh for a second. Oops. And let's do this. Now, at any point, if you want to double check your sketch to make sure it doesn't have any disjointed ends, you can come over here and turn that on. I point that out because that is a concern when you start modeling there. Now you see this is bent. You can do this a few different ways. Let's go ahead and I'm going to model it bent just to show. I'm going to go ahead and do this. And turn that all off. And I'm just going quick, so don't judge me on my sketching techniques here. There's a bunch of different. There we go. All right, so we'll go ahead and get our extrude ready. Actually, I should have stayed in there again. So there's that. And then we can go ahead and extrude this both directions. Just a little bit bigger there. There. And then another thing, I went a little big on that on this. So let's just shrink that down. And then on the top, let's go ahead and select that. Again, I like using regions because it's like a saved selection. I can come back and make changes to it really easily. And then I could come over to the Loft Wizard. This is way overkill for what we're doing here. But I just thought it would be fun to use the Loft Wizard here. We got to use the Loft Wizard at least once in a project. And then let's lower that down to like 5. Lower this down to like 10. You don't need that much resolution there. And you can check your deviation. So there, we just did that. There's that. And then we can offset it too. Oops. And flip the distance. Let's turn our solids on. There we go. So we could do a cut. And then here's one mistake that I made. So let's get out of that real quick. The new defaults for the software made this merge. So I have to open this up, change it to insert. And then the other thing is make sure that that completely intersects. I think it does. Let's just take a chance. Let it ride. Target bodies, this, next. Yes, it did not. Okay, so we'll just come back over. And you see that we didn't quite intersect all the way there. That's what that is. So I'll just get out of here. And just do an extend here. It's probably only that one. And then cut. Tool entities. Boom, boom. Target this. And hide these. So completely unnecessary to model it bent that way, but I just wanted to show, like, if you were going to do it that way, this is how you would do it. So this has been my overall workflow. So we went from putting the scanner down, merging and all of that, aligning, align to world, cleanup of the mesh as well was in there, and then modeling this entire thing, just stream of conscious, just walking through. Hopefully this was helpful to you, just to see an entire workflow, wire to wire live. So that's kind of the way I did this, is just went through the workflow, modeling this entire thing from scratch.